Okay, so the world's longest par 3. The tee of the world's longest par 3 sits atop South Africa's Hanglet Mountain at 400 meters above the green, and it can only be reached by helicopter. The horizontal distance to the green is 359 meters. Neglect air resistance and answer the following questions. If a golfer launches a shot that's 40 degrees with respect to the horizontal, what initial velocity must she give the ball? And B, what is the time for that ball to reach the green? All right, do we have any golfers in the class? And Jaden, you can ask any questions from the book, expert TA, challenge problems, literally any question today. All right, so Train Master's a golfer. Excellent. I am a terrible golfer, but I still kept it.
I know a little bit of golf, but not much.
All right. So you tee off up here on top of a mountain. Right. Here you are, you've just completed your swing. The ball is traveling like so, 40 degrees above the horizontal. And the green is down here. Here's where you're shooting. Problem specifies that the horizontal distance to the green is 359. The vertical distance is 400. All right, so here's our picture. We're going to go ahead and say that to the right is positive x and up is positive y. Okay. So that covers step 1 and 2. And as a reminder, here's our method. We start by drawing a picture. We specify the coordinates we're going to use. We break down any vectors that need broken down. And then we grab this in our toolbox to see what physics we can bring to bear on this problem. So we've done step 1 and 2, drawn a picture, specified coordinates. Let's write down all our quantities as vectors before we go any further. So the initial position that we are teeing off from, right, it'll be our initial position in the x direction, our initial position in the y direction, and the values for those, we're going to start at 0 in the x direction, 400 in the y direction. And then our final position will be, again, some coordinate in the x, some coordinate in the y, but we're going to end up 359 meters to the right of where we started it, and we are going to end up at height 0. So here we've implicitly said that the green is at height 0, and the tee is at x equals 0. The acceleration we're going to be feeling, or our ball is going to be feeling rather, will be nothing in the x direction and minus g in the y direction as per normal. So the only thing we really need to break down is this initial velocity. So I'm going to draw this triangle a little bigger. This is our initial velocity. Angle's 40 degrees. What's our initial velocity in the x direction? Anybody? Matthew Keys, I think you were trying to say, yeah, that's right. Okay, that's right. So we don't know what V naught is, but whatever it is, the x part is going to be V naught cosine 40, and the y part of our initial velocity will be V naught sine 30. Sorry, 40. All right. So when we go to write down our initial velocity, it'll be some amount in the x direction, some amount in the y direction, and that'll be V naught cosine 40 and V naught sine 40. Now we don't know what V naught is. In fact, that is what question A is asking us. Like, what is the initial velocity, or should say the initial speed? With what initial speed must our golfer hit the ball? Okay, so there's step 3. Step 4, we've got position, we've got initial velocity, we've got acceleration. What tool does it seem like we're going to want to use to solve this problem? Kyle, what do you think? What seems likely? No? Nothing? Josue, what do you think? We've only got 4 choices, so you've got a 1 in 4 chance of nailing it on the first try. K2, I agree. That's got everything we want. Right, initial position, final position, initial velocity, acceleration. Yeah, let's definitely pull that out to work on this problem. Oh, that's the same color as the mountain. We don't want that. What color have I not used? Red. All right, quick stock. How many unknowns are there in this expression? Like, how many of these variables do we not know a value for? Jaden, that's right, we don't know t. Is there anything else we don't know? So good guess, Matthew. We actually do know what a is. It's 0 in the x direction, it's minus g in the y direction. Kelly John, you've been quiet today. Oh, Eric saved you. V naught is still unknown. Yeah, that's fine, Eric. Right, we don't know V naught, we don't know t. That's 2 unknowns. But we've done enough of these to realize now that there's actually two scalar equations packed away inside here. So if we split this up in the x and the y directions, we're going to have two equations, two unknowns. We can totally solve for that. So let's start with x equals x naught plus v naught xt plus 1/2 ax t squared, and y equals y naught plus v naught yt plus 1/2 ay t squared. So looking at the x equation, there's a couple of those terms that are zero. Which ones are zero? Palenci, you want to... there we go. I was just going to call on you over, and you answered for it. Yeah, acceleration in the x direction is 0, and Eric, you are also correct. The initial x is also 0. So this term is 0, this term is 0, and we actually, we know what x is, we don't know what t is, we don't know what v naught x is. So unfortunately, this is as far as we can go in this direction. What about the y direction? Do we have anything in the y direction that's going to be 0? Good guess, Trainmaster, but actually remember, initial velocity is something we don't know. So that's an unknown. But Eric, that's right. The y final is going to be 0 because we said the green is at height 0. So when the ball's on the green, it'll be at height 0. So we can rewrite this. 0 equals, right, our y naught's going to be 400. But we're not going to plug in any numbers just yet because we're going to do some pretty nice algebra, and it's easier to do algebra without plugging in numbers. I am going to plug in the minus g for a here, though. So it looks like we have two unknowns in our x equation. We also have two unknowns in our y equation, right? We have a v naught and a t unknown in both of them. So there's no easy trick this time to do a solution. We have to actually solve a system of equations the hard way. I'm going to give us some space to work this one out. So the x direction looks simpler. So let's start with that and say something like, well, t is equal to x over v naught x. And then we can come over to the y direction and plug in that expression. So we have 0 equals y naught plus v naught y times x over v naught x minus 1/2 g x over v naught x squared. Is everyone with me so far on the solution to this system of equations? All right. So we did actually break down a triangle for initial velocity on the last page. So let's plug in our expressions for v naught x and v naught y in terms of just v naught. So we have 0 equals y naught plus, and a v naught y was v naught sine 40. And then we have x over v naught cosine 40 minus 1/2 g x squared over v naught squared cosine squared 40. All right. So let's do some simplification here. Derby, can you give us a hint as to what to do next? All right, before the end of the class, I'm looking to hear some input from Derby, from Morales, from Polarcat, and from Coranda. Well, that's not a bad idea, Prada. If we replaced x with v naught xt, that's certainly a valid replacement, but then that's actually going to increase the number of unknowns, right? Because x is a number we know. It's 359. But v naught x is a number we don't know, and so is t. So if taking a look at this, right, sine 40 is a number, y naught is a number, right, it's 400 meters, x is a number, it's 359, g is a number, it's 10. So it actually looks like we only have one unknown in this equation. And we don't even have to use the quadratic equation to solve for it this time, because this linear v naught, it actually cancels. So we have 0 equals y naught plus x sine 40 over cosine 40. That's tangent 40. That's an extremely messy tangent 40. Minus x squared over 2 all right. So remember, our goal is to solve for this v naught squared down here. So when we're setting down to do serious algebra, I doubt anyone has actually said this to you explicitly, but does everyone remember what PEMDAS means? Somebody tell me what PEMDAS is a mnemonic for. Yeah, it helps us remember the order of operations. So when we are evaluating an expression, first we evaluate things inside parentheses, then we evaluate exponents, then we evaluate multiplication and division, then we evaluate addition and subtraction. However, when we are solving, we go in the opposite direction. So if we need to solve for something, we go right to left. So first, anything that is attached to our variable by addition or subtraction, that has to go. The things that are attached to our variable by addition are this y0 and this x tan 40. So we're going to subtract those to the other side of the equation. Alright, so now there's nothing that's attached to v0 via addition or subtraction. So now we're going to get rid of things that are attached to it by multiplication or division. In this case, the negative sign, the g, the x squared, the 2, and the cosine squared 40. So things that are in the denominator get multiplied to the other side. So 2 cosine squared 40. And things that are in the numerator get divided to the other side. And notice that actually every term in this equation has a negative sign. So when we move the negative sign off of our v0 squared, all the negative signs just cancel. Okay. So now v0 squared only has, like, the v0 only has, exponents attached to it. Notice we can, so what we're going to do is we're going to take the reciprocal of both sides and then take the square root, and that'll get v by itself. So let's do those steps one at a time. So if we take the reciprocal of both sides, we have gx squared over 2 cosine squared 40 times y0 plus x tan 40. And then we will square root the whole thing. Alright, now and only now that we are done with our algebra, and it was, not trivial algebra. So now that we're done with our algebra, we can plug in numbers without things getting too messy. So we've got 10, 359 squared,
Excuse me?
Yeah.
Why did you put 1059 or 1035 9 squared for xgx? Is that just the multiplication for them?
Yeah, so g is 10, and x was 359.
Oh. Okay. Sorry.
Yep. Alright, do we have any other, does everyone follow this algebra? Does anyone have any questions? Did I make a slip up somewhere? Please feel free to speak out. No, everybody feels good about this? In that case, who's got a number for me? Who's plugged this into their calculator already? Is that a 1 or an r at the square part? Yeah, this thing up here, that's supposed to be to the 1/2 power, right? Because taking the square root is the same as a 1/2 power. It's just, neater to write it as a 1/2 power. Morales says I got 39.57. That is also what I got. So this initial velocity is 39.57 meters per second. Does that seem like a reasonable number? What other things go about 40 meters a second? How fast is 40 meters a second? Like, is it fast? Is it bicycle fast? Is it running fast? Is it speed of light fast? Airplane fast? Yeah, cars get that fast. Yeah, cars can go that fast, but not legally. So, right, it's going to be something like 90 miles an hour. All right. So good. So yeah, that seems like a really good answer. 39.57. Now that we have a value for V naught, well, now we can come back to our expression for t. So t is equal to 359, that's our x, over 39.57 cosine 40. So we're looking at like close to 12 seconds of hang time. Thomas, did you have a question?
No, I didn't.
Okay. All right. Does everyone feel like they could reproduce this work if it were on the exam? All right, so if this question were on the exam, could everyone reproduce it? If your answer is no or maybe, then you should take this time to ask a question. Can you go back to the sketch? Wanted to get a screenshot? You bet. I also am recording this and it'll go up on YouTube. Prada says it seems quite long for a question to try. Maybe. I mean, I explained it in excruciating detail. So it took longer than, it might take. But also, you're going to have a little over 2 hours for 6 questions. So I kind of expect each problem to take you at least 15 to 20 minutes. Can you go over the beginning of the solving for V naught? I'm confused on the first step of moving that gx squared term. Okay. Wilver, are you talking about this step with the arrow on it, or see if we label this A, B, C, D, E, which line? D to E. Okay. So G and x squared are attached to V naught via multiplication, right? So we need to divide them to the other side of the equation. So rather than dividing them onto each term, I just put parentheses around the stuff that was already on the left-hand side, and then put a 1 over gx squared for the gx squared part. And since the 2 cosine squared 40 was in the denominator, to get rid of it, to get it off of the right-hand side, we had to multiply it. And so when we multiplied that, both sides by 2 cosine squared 40, we end up with a 2 cosine squared 40 in the numerator. Cool. All right, any other questions before we go on to another problem? Can I do 100? That is exactly my plan. So, in honor of the season, we should definitely do a football question. So we have a field goal kicker who kicks it at 45 degrees to the horizontal, which is the angle you want to kick at if you're trying to maximize the distance that you can kick a ball. When the kicker is 45.7 meters away, which means basically he's on the 35-yard line, the ball just clears the 3-meter high crossbar of the goalposts. Okay, so that tells us what the trajectory of the ball must be. So, part A. At what speed must the kicker kick the ball in order to get this trajectory where we just clear the goalposts? And 2, the second part, in addition to clearing the crossbar, the football must be high enough in the air early during its flight to clear the reach of the onrushing defensive lineman. So, can a lineman block the kick that we solve for in part A? All right, let's add in. So we already have sort of a picture, but we definitely don't have all the information we need in this picture. So the angle is 45 degrees. The distance to the goalpost is 45.7 meters. The height of the goalpost is 3 meters. And we'll come back and we'll do the drawing for part B and C when we get to that. For now, let's just focus on part A. this ball is going to have some initial velocity. All right. So there's our picture. We're going to be simple and say that positive x is to the right, positive y is up. Starting next chapter, we're going to start to play with the coordinates a little more. But for now, yeah, positive x to the right, positive y is up. And let's write down our information. So we'll go ahead and say that the initial placement of the ball, that's the origin of our coordinate system. So the initial position of the ball is 0, 0. The final position of the ball, that is, as it goes through the uprights, is going to be of the form xy, and that's going to be 45.7 meters in the x direction, 3 meters in the y direction. The acceleration the ball is experiencing is just gravity. And we have initial velocity. Now this is going to be very similar to how we broke down the initial velocity in the last question. So if we have an initial velocity, the x part of that is going to be whatever the initial speed is times cosine 45, and the y part is going to be whatever the initial speed is times sine 45. All right, so far so good. Anyone have any objections or questions? If not, what's our next step? What do we do next? Right, we've drawn a picture, we've specified our coordinates, we've broken down our vectors. What's step 4? Excellent, Eric.
Don't
Physics.
don't you construct the equation now?
Yeah, that's right. We reach into our toolbox, and once again, we're dealing with initial and final position, initial velocity, acceleration. What does it look like we're going to need in order to solve this problem? Here's our tools. Is it K2 again? Yes, it is K2 again. K2 is our workhorse. K1 and K3 are more of a specialty item. Okay, so we have S equals S naught plus V naught T plus 1/2 a t squared. What are our unknowns in this equation? Matthew, that's right. We don't know time. But what else do we not know? Yeah, we don't know V naught. That's right, Eric. That's exactly right. So, in essence, this is the same as the golfing problem, right? we have the same unknowns, we're using the same equation, so the math should look pretty similar. Let's see what we've got. So in the x direction, it's going to be v naught xt, and in the y direction, we're going to have v naught yt minus 1/2 gt squared. We're going to do exactly the same trick as we did in the golf problem. We're going to say, well, if this x equation is correct, then that must mean that t is equal to x over v naught x. And then we will go ahead and plug this into the equation on the y side. So y equals v naught y x over v naught x minus 1/2 g x over v naught x quantity squared. Just like last time, I'm actually going to give us a little bit of room to do this algebra. All right. And now that we've eliminated t from our y-side equation, we actually only have our v naughts as unknowns. So we do the same thing we did last time. We replace v naught y with v naught sine 45. Right, times x over v naught cosine 45. And over here, 1/2 gx squared over v naught squared cosine squared 45. Matthew Keys, I've seen this episode before. Yes. Yes, you have. All right, so in the first term on the right-hand side, the v naughts cancel. Sine over cosine becomes tangent. And we end up with basically the same expression for v naught. So on the left-hand side, we're going to have y minus x tangent 45 times 2 cosine squared 45 over gx squared. The only difference is we're going to have a negative sign out here this time, because we didn't have a negative sign in front of all the terms, so we couldn't just cancel them off.
Wouldn't the g squared, because you put g or gx squared on the right side, on the bottom, is that supposed to be there?
Yes. So on the right-hand side, it was in the numerator. So to get it onto the left-hand side, we had to divide. So it ends up in the denominator. But then in a moment, we're going to take the reciprocal of both sides. So it'll end up back in the numerator. So thanks for spoiling the twist.
I'm sorry.
So gx squared over 2 cosine squared 45. And I'm going to take this negative sign actually inside the parentheses and use it to just reverse the order of these two terms. So x tangent 45 minus y. Square root that bad boy. And there we go. There's our initial velocity. Someone want to plug that into a calculator for me? Ratings or degrees? Excellent question, Eric. The problem gave it to us in degrees this time. So yeah, the 45, the tan 45 is going to be 45 degrees. .12. Okay, excellent. Not quite as fast as a golf ball, which makes sense. Football's a little bit bigger. And we actually don't care about the hang time for this particular problem. So yeah, so if you can kick a football at 22 meters a second and you aim it properly, you too can make a 45-yard field goal. Does anyone subscribe to the Mark Rober YouTube channel? Or does anyone know who Mark Rober is?
This is Matt Prater.
That's right. He just posted a robot, football kicking robot. Here's the link to it.
Yeah.
What's up, Matthew?
Oh, no, sorry. I was stretching.
So Eric Ramsey asks, why did y minus x tan 45 turn into x tan 45 minus y? Excellent question. This negative sign here, I distributed that onto the parentheses in here. So we had a minus y plus x tan 45. And that was just an aesthetic change because aesthetically I find negative signs displeasing, so I try and write things down with as few negative signs as possible. Jaden says, for clarification, you always want g equals 10 rather than g equals 9.81. Yeah, I mean, when you are designing bridges, you know, in the future, you're all going to be great engineers. You should probably use g equals 9.81. But in this class, since I'm more interested in method than final numbers, go ahead and use g equals 10. Not a problem. If you can dodge a wrench, you can kick a ball. Excellent reference, sir. Okay, so this is part A of our football question. Now that we know the initial velocity of the kicker, let's take a look back at our diagram here. Part 2 of the question says, if we have a blocker and he's 4.6 meters away. And this dude can stretch 2.5 meters. Can the defender block the field goal? So now that we have our V naught from the previous section, we can actually rewrite our equation here. So in fact, at any given time, S of t is going to equal V naught, which is equal to, say, 22 cosine 45, 22 sine 45, minus 1/2 0 10, or actually we should do plus 0 minus 10 t squared. So there's our full formula for position of the ball as a function of time. If the defender is 4.6 meters away, how much time until the ball gets to him? All right, so we can take this equation and say, well, if x is 4.6, that's going to equal 22 cosine 45 times t, and then the x part of the acceleration is 0. So how much time does the defender have to react? The time he has to react is 4.6 over 22 cosine 45, which is not much time. Eric Tata says, where did you get the 22 from? From our last bit of work solving for the initial speed. And then I rounded 22.12 to 22 because I really can't be bothered with decimals on a Monday. Alright, so 4.6 divided by 22 cosine 45, I get 0.296 seconds. Right, so it takes less than 1/3 of a second to reach the defender's position. What's the height of the ball at that amount of time? Well, the height of the ball as a function of time is equal to 22 sine 45 times time minus minus 10 divided by 2 is minus 5. So say minus 5 t squared. If we plug in 0.296 for y, so y at 0.296 seconds is, we just plug that in for t. So it's going to be 4.17 meters in the air. That is well out of the reach of any human defender. you have any questions on this part of the problem? Palencia asks, technically, would it be 4.17 minus 2.5 to factor in the height of the player? Or did we do that already to see if he can catch? Sort of. So if the ball had been 2.5 meters or less high, then the defender could have reasonably blocked it. So if we wanted to say, well, how far over the defender's fingertips will the ball sail, then yeah, 4.17 minus 2.5 would give us that. Yeah, 2.5 is a lot, right? That's I mean, maybe he can jump an extra 2 meters. So 2.5 is just when he's stretching. So you've got a defender who's already a tall dude and he's stretching up in the air and he can reach 2.5. Maybe he can jump another meter in all that gear. Maybe, but I don't know. I doubt it. I've seen some amazing blocks, but also, like, the ball reaches the defender like less than a third of a second after it's kicked, so there's no way a defender is able to time a jump for that. There's no way a defender could time a jump unless they're incredibly lucky. And yeah, McHenry, it's only asking if the ball will clear the height. That is correct. So 4.17 meters is definitely bigger than 2.5 meters, so it will clear. All right, unless there are some more questions, I think we're going to end it here for today.
Can I just say one thing?
Sure, absolutely.
Regardless of if we just assume that the guy is like 2 meters tall, so about like a little over like 6 feet or whatever, if he was able to jump to if he was able to get to 4 meters, that is downright incredible. Like, that is just that is like superhuman.
Yeah, so
that is.
Yeah, you need a linebacker who's also an Olympic broad jumper. I don't know if there are any of those, but I would love to see it. Oh, there we go. Palencia says Javier Sotomayor is the current men's record holder with a vertical jump of 2.45 meters. So humanly possible, yes, but extraordinarily unlikely.